पता है इसको बोलते कैसे हैं?
नहीं, मुझे नहीं पता है इसको कैसे बोलते हैं, लेकिन मुझे एक ऐप के बारे में पता है जो इसे अपने भाषा में बदल सकता है। उस ऐप का नाम है अक्षर। जो देखो, ये एक अंग्रेजी का शब्द है, तो इसको हिंदी में बदल सकता है। अब हम लोग इसको यहाँ पे लिखेंगे, उस शब्द को, और इस बटन को छूने से वह शब्दों में बदल देगा, अपने भाषा बोले वाली भाषा में। देखो, ये शब्द बदल गया है। अब हम इसे अपने बोलने वाली भाषा में पढ़ सकते हैं।
अरे हाँ, ये तो मैं पढ़ सकती हूँ। इसको बोलते हैं कॉन्कॉक्टेड।
अरे क्या लिखा है? एक्सक्यूज मी, ये क्या लिखा है? एक बार बता।
सही बोल रहा हूँ इससे।
मुझे समझ नहीं आ रहा, फिर से बोलो।
I don't understand. You're saying you don't understand what's written?
आपकी भाषा मेरे को समझ नहीं आ रही।
Say water.
मुझे
You can use this app.
ओके।
Save water, save, don't waste it.
ओके, मुझे समझ में आ गया।
Did you understand?
हाँ, समझ में आ गया।
It's a
धन्यवाद।
transliteration.
और-
Okay.
Such is the situation of many different travelers and explorers that travel to far off lands in foreign places and are often finding themselves in places where they can't understand the language or the script that's written. This is the problem that we're going to solve with our solution, transliterations tool for street signs. So the proposed solution that we're talking about is an AI-powered script transliteration app, Akshar, that allows users to understand the written content written in any Indian language and convert it to a script that they can read. This objective is to design and develop a mobile and web-based application capable of seamlessly bridging India's linguistic diversity through script transliteration. The problem that's solved through this is just like the problem that we were talking about in our video. It's if a traveler from Andhra Pradesh may find it difficult to read signboards written in Punjabi, or a pilgrim from Manipur might not understand the text written in Malayalam while visiting Kerala. And this creates a language barrier which is not correct for people living in the same land. And this is how our app works. For a mobile user, it's a login page with a main screen and settings. In the settings, they can toggle theme, app settings, and for the main screen, you have a language picker. You can pick the language that you want to translate. It will send a request, and through Gemini API call, Indic NLP, and local ML model that we're using, it will transliterate through Google ML Kit, and finally we'll get the transliterated output here. So its dedicated focus is a faster purpose-built interface just for transliteration. Unlike cluttered translation apps, it's reliable because it has an offline mode too, because it guarantees functionality without an internet connection, which are not possible in most of the models, and it's community driven, and it has a great accuracy too because it learns from user feedback to provide more contextual accurate results. It's lightweight and fast. The app size is very small with optional language packs that allows it to run smoothly on any device. So the core technologies that we're using is built with Flutter and Dart for high performance and cross-platform capability. For AI and machine learning, we're using for online transliteration, we use Google's Gemini API for accurate cloud-based processing. For image to text, we use Google ML Kit for recognizing text from the camera or gallery. And for offline transliteration, we use local models like Indic NLP for on-device functionality without the internet connection. For data packages, the local storage SQLite is used for managing user data and history, and device integration happens through key packages like camera and image picker for core hardware access. And this is the basic flow of our app. It's a login register like I talked about in the previous slide. Main screen, settings, you can pick your language. It is transliterated through the online ML model or Gemini API or local ML model, and the transliterated output appears here. It can be an image input, it can be a text input. So, talking about the feasibility and the viability of the project, it's highly feasible, viable, because it leverages existing AI models to meet a clear demand in multilingual regions. It ensures high accuracy across different languages and contexts. So our strategy is always to implement a feedback system for community-sourced corrections and offer multiple transliterations, suggestions for ambiguous words. High operational costs from API calls as user base grows. Our strategy will be to develop a hybrid system that uses free offline models for simple tasks and reserves the powerful cloud for more complex ones. It competes with established and all-in-one translation apps, as we market our app as a specialized, faster and more intuitive tool that excels at one thing, offline transliteration. And lastly, it's large app size and potential performance lag from local ML models, which doesn't happen in our app. We keep the initial download small and offer optional downloadable language packs that allows users to only download what they need. So the impact and benefits of this project are as follows. For students, it simplifies learning new languages and reading diverse scripts. For travelers, it makes navigating new regions effortless by instantly deciphering signs and menus. For communities, it bridges communication gaps, fostering better local commerce and social interaction. It has a social benefit because it promotes cultural exchange and linguistic inclusivity. It has economic benefit because it boosts local tourism and commerce by making traveling easier by translating the local scripts. And it has an educational benefit because it acts as a powerful free tool to improve our literacy and cross-language understanding. So this was the research and reference materials we used. For frameworks and core APIs. We use the official Flutter and Dart framework and the documentation for it. Google Generative AI documentation for the Gemini API, and Google ML Kit for text recognition we were using. It was official guide on the on-device Mozilla capabilities. Key libraries were Indic NLP library, GitHub repository of Anup Kuttan for Indic NLP library, SQLite package for the Flutter plugin for SQLite, pub.dev link for pub.dev packages on SQLite. Conceptual research for the transliteration that we were doing was taken from a survey of machine transliterations, and the translation versus transliteration and what's the difference between them. Both are articles. One is the academia article and the other was from various linguistic resources. Thank you.